And today we're just talking about two events. So we're going to continue talking about these Venn diagrams, which is the idea of sets. It's still a connection to set theory. But we're going to do applications. So it's going to be a little bit more word problems, our understanding of the concept. Now today we're just going to focus on the concepts of different situations and how these Venn diagrams are helpful. Tomorrow we'll do a little bit more practice, just like we did yesterday. It's an asynchronous, so it's not mandatory in regards to the Nearpod practice, but it's highly recommended because you probably won't know what to do for the homework and material. But I mean, if you really grasp everything, it should be okay. So there's two ways that we can do these Venn diagrams. So we can say something like, these represents, we have this Venn diagram right here, and we can say that these are sunroofs, and this is air conditioning. And it should be noted that I'm referring to those circles. So even though I've written outside the circle, which you've kind of seen, I'm referring to those circles right there. And these are just, these represent just cars in a neighborhood. All right. And similarly, I could have also just defined A as cars with sunroofs and B to be cars with air conditioning. Okay. And we have A and B. I want to note that that's still referring to those circles. So the purpose of this lesson is to try to explain what these problems mean. So in these examples, we're going to utilize this one right here. And if A and B are such, then what does this represent? So what does the shaded area represent?
Amount of cars with sunroofs.
Amount of cars with sunroofs. Okay, and I haven't put the numbers in there, but there will be numbers in there. Good. What about on the other problem, if I did this? What does this represent? What does this shaded area represent?
Cars with air conditioner.
No. A little bit more. That does not represent just cars with air conditioner. That would be the entire circle as we just saw on the Venn diagram to the left.
Will be the amount too?
Well, you can say amount. You don't actually, you don't really need to say the amount. We can just say cars with sunroofs on the one on the left. So if the entire circle was shaded, that would have been cars with air conditioning. But the entire circle isn't shaded. The part of the circle that's shaded is the cars with sunroof and
cars with air conditioning.
no, we just said that. Sorry, with the shade area is the cars with air conditioning. Sorry, I was just reading the one on the left for a little bit. So, and if the entire circle was shaded, it would have been the cars with air conditioning. If the entire circle B, but the entire circle B is not. So remember, so if I remember, and if you think about this, there's individual regions in this picture, right? We have this one region right here, this one region right here, this one region right here, this one region right here. If a single region is shaded, it's always an and. Remember when we did those problems before in the last few days when we only shaded one of the 8 regions for 3 of them? Those were the ones that were just and the intersection and intersection. So this is an intersection of a region, which is in other words a way for us to verbalize the word and. So if a single region is shaded, this represents an intersection of the events A, B, A prime, or B prime. Okay? So in this problem right in here, so we verbalize this with the words and. Okay? So this region represents cars with air conditioning and the region it is with air conditioning because it is inside and notice that the other region is not within, so it is outside of A. So when you're outside of A, it's without. Or you can say the words with no. So it's cars with air conditioning and without what?
Without sunroof.
Without a sunroof. Now notice in the previous picture when it was just one single circle. So it didn't even matter that there was another circle in there. It didn't contribute to the shading on that one on the left. The air conditioning circle didn't even matter. The shaded region really just ignored that circle was even there. So that means we're just talking about one singular event in that case. All right. If the circle plays a part in the shading, then that means it's going to play a part in the description of what is happening with the problem. Let's try another one. Let me just try another one here. Same thing, A and B are the same things. All right, so the question here is, are we talking about two events here? Or are we talking about one event here? Let's first get to that understanding. Yes, there's two events in the Venn diagram, but does the shading, in terms of a verbalization of the description, we describe the shaded region. Do both events matter? Does the shaded region take into account both events? Yes or no?
Yes.
The answer is no. Does event B matter in the shaded region?
No.
The answer is yes. Striking out over here. B does matter because you can see that the shading stops at circle B. So the circle of B acts as a barrier is how I like to think about it. Does event A matter for the shaded region?
No.
No, it does not, because we did not even look at it or pay attention to it when we did the shading. The shading went right through the lines of circle A, and of course, because of the parts in the middle, at no point did we even utilize. It's like if I had erased A from this, if I erased that circle A, right? If I had erased that circle part of the A, it would not have changed the shading of the problem. So A in this problem does not matter for it. So what I'm saying is here is that if I had outlined here like that, if this A part doesn't even matter that it's there, the shading went right over it. So in this question, in the description of this region, only event B matters. And of course, B, as we just said, was cars with air conditioning. So what does this represent? What does this region, what does this shaded air region represent? Cars what?
With air conditioning.
No.
Without.
Why?
I don't know.
Okay, well, I need you to know first. I don't want to just keep guessing.
Cars with sunroofs.
No. That
But with
sunroofs is A. We just said A does not matter. So there's events A and there's B. A does not matter in this shading. But this region right here, we can describe the shaded region actually as just B prime. That's what this region represents. This is the shaded of B prime. This one over here, this region is region A, and this region right here is B and not A. Okay? So it is outside of B, so that's why it's the complement. That's why it's B prime. It's B prime because it's outside of B. And when we say outside, this means without, not, no. There's a lot of different words depending on the context of the problem. So this represents cars without air conditioning. This represents cars without air conditioning because the sunroof region doesn't even matter. And this region is represented as B prime. So we can utilize that connection and a notation that we've used about the intersections or unions and so forth to get us an idea of the problem. Let's try another one. So the goal of this problem is to describe, again, the shaded region. Now I could also ask you to describe the shaded region. I'm going to do this as A using set notation, and then B, describe the region in context. So there's two questions I'm going to ask you right here. First off, what is this region that is shaded using set notation? And describe the region in context. So one's a sentence, one's a mathematical symbols. So how many regions are shaded?
Just one.
Just one. And if it's just one region, we know for certain that it's a what type of problem? What is the vocabulary? What is the symbol? What type of are we're going to use both because there's one region I always know, here's another way of thinking.
It's an intersection.
It's an intersection. Very good. So this is an intersection because there's one single region. So that means this problem is an intersection. And what is the intersection of?
AB.
A intersection B. And so now let's describe this region so that it's A and B, or with A and with B, however you want to think about it there. So these are cars with what?
Oh, sunroofs and air conditioners.
Sunroofs and air conditioning. Okay. Let's talk about the union of regions. Or actually, we know all that good stuff. We've already been learning lessons on them. So my next example A and B. Now I want you to note that the shaded region uses both events while being more than one region. So remember, if it uses both events but there's only one region, that's an and. All right. If this one uses what is that?
Can you repeat that?
It uses both events, so the shading uses both circle A to define the region and circle B to define the reason. So it uses both circles, but this is not an intersection, because an intersection will only have one region. So there's more than one region shaded. So
It's a union.
it's a union. It's a union. Now, we verbally describe union with or. Or. Intersection is and, union is or. So one of the things that I've been practicing with you is to be able to describe this region using notation. So if we describe region with notation, we know this is a union. And is it inside or outside of circle A?
Inside.
So we just use a plain old A. Is it inside or outside of circle B?
Inside.
So we just use a plain old B. Okay. So these, that's how we would describe it here. And if we describe in context of the problem, this would be cars, what?
Cars with some roads and no with and or air conditioner.
Cars with sunroofs, or, so we count them if they have a sunroof, if the car has a sunroof, or it has an air conditioning. And if we talk about this one has three regions. The regions of these cars are cars with just sunroofs and no air conditioning, cars with just air conditioning and no sunroofs, as well as the cars with sunroofs and air conditioning. So it has those three regions. If you wanted to describe, technically, if you wanted to describe each of those three regions, I guess you could do that. Doesn't make very much sense. But this region is all cars with either, we can even say the word either, a sunroof or air conditioning. And that's because we're shaded inside both of these regions. All right, so let's do a different example of a problem with different contexts, and we're going to actually put some numbers inside of here. All right? So new example. A represents people who drink coffee. And B is equal to people who drink soda. Question A, and yes, I did not even give you the Venn diagram yet. R, and this is more of a review. All right, so you're going to go, well, I don't remember. No, this is a review. R, A, and B disjoint. Or, you know what? Let me use a more common word. Mutually exclusive. We also use the word disjoint. Are the events mutually exclusive? If you look past into your notes, I gave you a Venn diagram that looks what mutually exclusive looks like. I've also explained it to you and we defined it.
No, they ain't disjoint.
So you're saying they are disjoint?
I say they ain't.
They ain't. They are not. Ain't is not a word.
Okay, they are not.
They are not mutually exclusive. Why? Yes, no will only give you no credit on this type of question because yes, no does not show me you understand. You can be just guessing a 50% chance.
Crap, I don't know.
Okay, then that means you're just guessing then.
No. I do just pussy.
The answer here is no. You're correct at saying the answer is no.
But
No, because you can drink coffee
I thought we were talking about the cars.
and drink soda.
I thought we were talking about the cars.
Why would you think we're talking about the cars? We're right above here. I have drink coffee, drink soda.
I forgot.
So you can drink coffee and drink soda. All right.
I need new glasses. I need a new prescription.
So if just as a review, as a reminder, if the Venn diagrams look like this is disjoint.
So, for example, if we have a car and a circle of a car and another of a fish, they are disjoint, right?
Well, if you're saying so if we're like one represented cars and the other circle represented fish, you can't be both a car and a fish, I guess you can say. So those would be mutually exclusive.
Nice.
Okay.
Now I get it.
All right. So, in other words, what this tells me is that the Venn diagram is here. You can also answer the same question here. Based on this Venn diagram, are they mutually exclusive? The answer is no, because there is some and in here. You can be both because these two circles overlap. And so most problems that we work on these Venn diagrams, most all problems that we work on are not mutually exclusive. So mutually exclusive means that they don't have any overlap. All right? If they do have overlap like they do in this picture, then that means they are not mutually exclusive. All right? And our numbers that we have here, so this is a survey of office workers. So we surveyed some office workers and we get 83 on the outside, 31 right here, 12 right here, and 25 right here. That's how many elements, in this case, an element represents an office worker, is in each of the events or not in the event. I mean, and each of these numbers represents an and. So question B. Describe the individual regions in context. So let's just do it right here. Let's just talk about what each of these numbers mean. All right. The easiest one is the overlap one. So let's start there. 12 workers what? That's our first one. The next one, 31 workers, 25 workers, and then finally 83 workers. Let's define these 4 individual regions. So the 12 is this region here. And every time we have an individual region, that means what type of set notation are we using? What type of event relationship is this? What do we talk about if we're only talking about a single individual region? Well, you had to be here, yeah.
No, it's not prime. I was going to say prime.
We talked about it up here in our notes, that if we have a single individual region, and all we care about is that region, if a single region is shaded, or we're talking about a single region, this represents an intersection of the events. So each one of these ones is technically, if I were to shade it, it would have been just a single region right there. So that means every one of these problems is an intersection, as we covered at the very beginning of this class. So 12 workers, so is it inside or outside of both circles? Is it inside circle A? Is it inside circle A?
Okay, you repeat the question again. I didn't hear you.
Is the 12 inside of circle A?
Yes.
Is it inside of circle B?
Of course.
So then this is A intersection B, which means this is 12 workers who drink coffee and then actually let me do some different color notations in here. It might help.
The purple. Purple is the coolest color.
And B and drink soda.
I thought we were talking about the workers.
We are. I literally say workers. These are workers who drink coffee or drink soda. Region A represents, all these numbers together represent the office workers. A represents those who drink coffee. B represents those who drink soda, of the office workers. All right. Let's talk about the 31. Let's talk about that region right there, the 31 region. All right, we're talking about this region right here. It's a single region, so we know it's an intersection. All right. Is it inside of A?
Yes.
So you just use a plain old A. We know it's a single region, so it's an intersection. Is it inside of B?
No.
No. So it's A intersection
A.
Well, that wouldn't make sense. A intersection A wouldn't make sense. We're using both events here. A intersection B prime. We're outside of circle B. We use the boundary of B. but we are inside circle A. Every time we're only talking about one individual region, this is an and, because there's only one region. We are inside circle A, but we are outside circle B for that region with the 31. So this is A intersection B prime, or in this case, 31 workers who, what?
Who drink coffee, but they don't drink soda.
If you said that, I would give you credit. I'd give you full credit. And don't drink soda. So now it's don't. I had that extra word don't. Not, right? There's a lot of words for the opposite, right? Depending on the context of the problem. All right, let's talk about that next region, the region with the 25. So we're talking about this region with this 25 now. There's only
the same A prime intersection B.
There you go. Why? Explain that to me. Why is it A prime?
Because it's outside of A, but it's on B.
It's outside of A, but inside of B. So these are 25 workers who
don't drink coffee but drink soda. I mean, not drink coffee but drink soda.
Don't drink coffee. And I want to notice, Eliana is saying but, and it's the same. But is another word that is not a synonym, but in the context of this problem, but and are interchangeable. They do this, but or they do this, and it's in the context of the vocabulary, they would be accepted for full credit. So I like to just keep it though very, boom. So I'm going to use just the word and because I know the intersection means and, but you can, in the context of this, you can say but. And drink soda. And what about the region with 83, which is everything outside of the circles?
A union B prime. Both prime.
There you go. Why is it?
Prime union B prime.
So it's still one single region, right? It's one of the four regions, but it's outside of both of the circles. So yes, it would be A prime intersection B prime. And so there are 83 workers who
don't drink nothing at all.
Well, that doesn't have the context of the problem because you have to say coffee and soda.
Don't drink coffee and soda. Don't drink both coffee and soda.
Now, I want to notice that Eliana also said it in a acceptable way of how he said it. He said the word both because they are both nots. If they're or you could also say things like neither, who drink neither coffee or soda. You could say that. That would also be appropriate because you're still saying the same thing. You're saying not to drinking coffee and not to drinking soda. Now, my recommendation for us in our course is to try to feel confident utilizing this, the strict words of and things like don't or not, with, without, the complementary words. Most of the time you can get away with utilizing things like but, neither, that or both, They can be utilized, but if you say it in the wrong mannerisms, you can be explaining an or, a union, versus explaining an and, which is an intersection. So do be careful on that. You can be very, just direct in using yeses and nos. Yes to drink coffee and no to drinking soda. You can say it's stuff like just like yeses and nos. Um, is acceptable. Of course, how well you want to write the description to make it, because you got to look at the problem and say, yes, that is describes exactly what the region is, but you wouldn't go up to somebody and tell them that way. And my hope is that you would explain it to them in the way you would say it, something like Elian is saying, and the word utilization he has. But I am more than happy with this. Now we'll continue. Well, actually, you know what? I have time for one more region. Tomorrow we're going to practice these problems with shading, and I'm going to actually look for you to write the answers or to identify the regions. We'll do some Nearpod on that. But my last one is, if I had this, and we're still talking about the same one. So we have the 83, the 31, the 12, the 25. And if we shaded, I shaded this. It's the same thing as we just did earlier. What does this shaded region say?
B union A. I mean A union B.
It's a union, so this is A union B, okay. We also know that the N of A union B, we can find that.
By adding 31, is that 12 and 25?
So that's
and 83.
No, 83 is not shaded.
93.
So what is the cardinality of A union B?
Hold on. 31 plus 12 plus 25. 68.
Very good. So describe the cardinality. Describe the cardinality.
Amount of work that there is soda.
How many? You know the amount.
1.
How?
Plus.
How many workers? You said the amount. We know the amount. Help them out here. How many workers? We just found it.
31. No, 68.
68 workers. What? Describe the A.
Drink soda, coffee.
Drink coffee. Describe the.
Drink.
What is the
coffee, soda, and the.
Drink coffee. What is the union? How do we verbalize the union? Somebody?
And.
How do we
Or. Coffee.
Drink soda.
Drink soda.
68 workers drink coffee or drink soda. You could also say things, you can say it like 68 drinkers drink either coffee or soda. You can add that either to make it sound a little bit more conceptualized in terms of it. But I want to note that we're talking about this cardinality. These are all things we've done. Right now we're doing with 2 events. We're going to continue with 2 events and some practice for tomorrow and get some homework on it. And then Monday, we're going to get into 3 events and have 3 circles on them. So we got to make sure we master these 2 before we can move on to those 3. So the attendance overall, I'm very shocked in terms of how few students showed up today. That's not good in terms of the understanding. And there's also a significant amount of individuals who were running late today. We need to make sure that we're on time. So I'll update the attendance during my next free part. As of right now, those people who were late were marked absent, and I'll update that to tardy and what time you came in after that part. That's all I have for you. It is 9:05. I'll see you tomorrow.